The graph of y equals f of x is shown below, and the key points A, B, C and D have coordinates as shown here. We want to complete the table of values for the transformations of the key points A, B, C and D of y equals f of x. And our first transformation is to f of x. Now from what we've seen, the x coordinates will stay the same and the y coordinates will double. So this one's going to be at -7, -8. This one will be at -4 with the x coordinates staying the same, and 4. This one will be at 0, -4, and this one at 6, 8. Then we want to do minus f of x. Now remember, that's -1 multiplied by f of x. So once again the x coordinates will stay the same, but the y coordinates will be multiplied by -1. So this one's going to be -7, +4. This one, -4, -2. This one will be at 0, 2. And this one at 6, -4. Draw and clearly label each of the graphs of y equals 2f of x and y equals -f of x on the axes above. Now I'm actually going to do the -f of x first. So we have -7 and 4. So that's going to be just here. -4, -2. Then we have 0, 2. And finally, we have 6, -4. So that's going to look like this. And that's going to be A dashed, B dashed, C dashed, and D dashed. Now, we're asked to describe each transformation. So if we look at C part 2, we can say that this is a dilation, that's the word we use for stretch, scale factor -1 in the direction of the y-axis, and this is the sort of language you need to use. But notice that this one is also a reflection in the x-axis. So when we have a negative number here, we get a reflection in the x-axis, and if the number is something other than -1, you're going to get a reflection and a dilation at the same time. Now, to make what we're doing clearer, when I do the 2fx, I've just removed the negative fx. So -7, -8. Then we get -4 and 4. 0 and -4. And then 6, 8. So if we join those up, so what do we notice? Well, first of all, let's label them. This is A dashed, B dashed, C dashed, and D dashed, which are the images of A, B, C, and D. Now, every single point on the black function is twice as far away from the x-axis as the corresponding point on the blue function. You'll notice that they cross the x-axis at the same points, and that's because when the function crosses the x-axis, its distance from the x-axis is 0. And of course 2 times 0 is 0. So both functions have a distance of 0 from the x-axis at the points where they cross. But everywhere else, this one is twice as far away from the x-axis. So to describe this one, this is part 1, we would say it's a dilation, and we have to use that word dilation, don't use stretch. Scale factor 2 in the direction of the y-axis. And if you describe it like this, you will always get full marks.